talk about a function. Let's say I have a current, and it's equal to 45 times the sine of 450t. And what I want to do is I want to plot out this function. I want to describe what the amplitude is. I want to find what the period is and what the frequency is. I'm going to start off by saying, what does a sine wave look like? So the sine wave will look like this. And the amplitude of the sine wave is 1. And this is pi, 2 pi, and this is pi, and this is pi over 2, and this is 3 pi over 2. Now this is a graph of a sine wave versus theta. Sine wave versus theta. And the first thing that's going to happen is this sine wave is multiplied by 45. So this height will be 45. So the amplitude of this wave would be 45. Now, what about the period? This is a period. And this period is equal to 2 pi. And so this is theta. And so to find the period, I'm going to set theta equal to 2 pi. So theta is 450t equals 2 pi. So now I want to solve for t. I'm going to divide this by 450, divide this by 450, and I have t equals 2 pi over 450. So I'm going to use a calculator, and I'm going to put into the calculator, turn it on first, 2 times second function pi divided by 450. 2 times second function pi divided by 450. Oh, time out. Time out. My calculator is not working. Going to do 2 times second function pi divided by 450, and I'm going to put the calculator into scientific mode, into engineering, and I have t equals 13.96 times 10 to the minus 3 seconds, or 13.96 milliseconds. So this is 13.96 milliseconds. So the period is 13.96 milliseconds. Now the frequency is equal to 1 over the period. So if I go y to the x, 1 with a minus sign, and take the inverse, so the frequency would be 71.62 hertz. So the frequency is 71.62 hertz. Okay, so what have we done? We've plotted a function. The function was 45 times the sine of 450t, and we plotted it using a sine curve, and the amplitude came out to be 45. The period came out to be 13.96 milliseconds, and the frequency came out to be 71.62 hertz. All right, thank you very much.